Hello and welcome to IT Program Design with UML. My name is Bhuvan Unhelkar and it's my privilege to present this course to you. Until now, you have learned programming, perhaps using various languages like Java or C++ or Python. I'm a very old time programmer and the first language that I learned was COBOL, commercial business oriented language, and Fortran. What is important to appreciate in this particular course is we are not learning programming because we assume programming as a given knowledge. So what is it that we are trying to do? We are trying to design good programs, good software solutions that will be of value to our users. The best of programming, which does not provide value to a business user typically, is a waste of effort. So our goal in this particular course is to work hard to learn the concepts of good designing of programs. And as a design, it could be generic enough to be implemented in Java and C++, for example, or Python. So what is it that makes a program great? What is it that we need to use in designing good programs? What are the constructs? What are the elements? What are the notations? And what are the tools? We are going to go through all of that in this particular study. I have given you some reading material, and at this point in time the actual material that you need to follow, and of course the additional reading material, is all provided by me, and we are going to follow the Unified Modeling Language UML in order to understand how we can design our programs better. Based on my experience of more than 2 decades of learning where UML came about and then utilizing it in practice as well as researching around it, I find that there are three typical aspects that a good program design needs to consider. First and foremost is understanding what is the problem. This is called problem space or business space, and we are going to model the business space, the problem space, using some of UML's constructs, diagrams, like use case diagrams, like activity diagrams, and high level class diagrams. When it comes to designing a particular solution that will handle the problem, we make use of class and sequence and state machine diagrams, for example, in the solution space. So it is in the solution space that you need to be more aware of the language of implementation, whether it is Java or C++, and how your class design reflects in the language of the solution. So in order to create these models, we are going to use a open source software called Star UML. I don't insist on you using it necessarily. If you have some other modeling software that you are using or have come across or is available to you, and you might even use the well-known Visio from Microsoft to create your models. But somewhere during this course, I'm going to get you to create the designs and generate code. And that code generation is automatically done by the case tool, but gives you a very good idea of how a design maps to a solution. And the third dimension of good program design is what I have called background or architectural space. So this is where component diagrams, deployment diagrams, and such background diagrams, composite structure come into play. We are going to experiment with, try out all those diagrams that make sense in the problem and the solution in the background space. And then when you move to practice, you will be able to apply this knowledge that you have gained in order to capture requirements, in order to produce good designs, in order to apply constraints or limitations to your designs. So that's what we are going to study in this particular course. Let me also briefly update you on the assessment structure. There are 4 parts or aspects to assessment. First is discussion questions. I'm going to post 10 discussion questions spread out over our 14 or 15 weeks. And I want each one of you to post a reply to that particular question. It is important that all students post at least one reply and perhaps more counter replies to other students' posts. This is an open discussion, it's not closed. Each student can see what the other student has posted. This will help you consolidate each module every week. I then have got 3 assignments which are all individual assignments, and you work on each of those assignments, which could be a modeling exercise, which could be a code generation exercise. Whatever it is I have presented in those assignments, this is an individual exercise and you submit those assignments. The third part is a substantial project work. Here I am expecting you to work in groups, typically 3 students, sometimes one more or one less, but I usually try and stick to 3 students per group. All students are marked equally, therefore it is important that you collaborate with each other and you work on this substantial project that I have given you. You make a draft submission somewhere in the middle of the term, and then you make a final submission at the end of the term, which also has got points or marks. And finally, there are 2 tests or quizzes, one midterm and one final, both comprising a few multiple choice questions and a couple of practical questions where you have to design using a tool and then post the answers. So these are the 4 aspects of assessment. I hope you will do a good honest work, and as far as I am concerned, I'll be looking forward to giving you the best grades I can, because that's what I would like to start off with. Total trust in my students and wishing you the very best. I look forward to seeing you during each of those modules, and take care and work hard. See you soon. This is Bhuvan Unelkar.